A threat is rising beneath the Pacific Ocean, silent, unseen, and dangerously overdue. It's not a matter of if, it's a matter of when. And the warning signs? They're already here. This is the story of the underwater volcano scientists fear could erupt by the end of this year, right off the coast of Oregon. Beneath 8,000 feet of frigid Pacific water, 300 miles off the Oregon coast, lurks one of the most dangerous and closely watched volcanoes on Earth.
Meantime, the University of Washington scientists are monitoring an underwater volcano expected to erupt for the first time in a decade.
The Axial Seamount. Perched on the volatile Juan de Fuca Ridge, this underwater giant is far from dormant. It's taller than Mount St. Helens and spans miles of fractured lava plains and hydrothermal vents. Scientists have been monitoring it for decades, not because it's quiet, but because it keeps coming back to life. It erupted in 1998, then again in 2011, and again in 2015. Each time the signs were clear: swelling magma chambers, rising seafloor, tremors like distant heartbeats. And now, it's swelling again. Faster, bigger, louder. The ocean may hide it, but the threat is growing. Pressurized, powerful, and patient. The monster below is waking up. If you want to stay ahead of what nature's hiding, hit subscribe and stick around to the end, because what scientists believe could happen next might just change the Pacific Northwest forever. The Axial Seamount isn't sleeping, it's shifting. And every tremor, every pulse beneath the Pacific tells the same story. Time is running out. In the past year, scientists from NOAA and Oregon State University have documented a wave of ominous activity deep beneath the surface. Swarms of earthquakes have begun to rattle the region. Hundreds of small, rapid-fire quakes clustering around the caldera. A clear sign that magma is on the move. But it's not just the shaking that's raising alarms. Instruments anchored to the seafloor, some 8,000 feet down, are detecting another danger: inflation. The ground itself is rising, swelling upward as pressure builds in the magma chamber below. It's happening faster than in previous years, with some sensors recording uplift at record rates. According to researchers, this is the exact same pattern that preceded past eruptions in 1998, 2011, and 2015. And the hydrothermal vents? They're changing too. These deep-sea geysers, usually stable, are now releasing hotter water and more volatile gases. It's like the volcano is breathing harder, more frequently, more violently. One scientist compared the situation to blowing air into a balloon, except the balloon is the Earth, and the balloon is close to popping. What makes this moment especially alarming is the convergence of all these warning signs at once. Seismic swarms, vent activity, inflation. Individually, they're concerning. Together, they're a countdown. And for the first time since 2015, researchers are publicly saying it. The Axial Seamount could erupt again, possibly within the year. The scary part? Unlike surface volcanoes, this one won't give us a glowing sky or ash clouds to warn us. Its eruption could be silent at first, hidden beneath miles of cold ocean. But the consequences won't stay hidden for long. Stick with us, because what happens next could be the first act in a disaster scientists have feared for decades. When magma meets water, the result isn't just explosive, it's unpredictable. And when it happens under thousands of feet of ocean, the danger multiplies. Underwater volcanoes like the Axial Seamount erupt in a world of pressure, darkness, and silence, but the effects can ripple violently into the surface world. Unlike land-based eruptions, Underwater eruptions are shrouded in cold, crushing water. At first glance, that might seem like a buffer, a way to contain the chaos. But it's the opposite. The interaction between superheated magma and seawater creates a volatile environment where steam explosions can erupt with devastating force. When the magma breaks through the crust and hits cold water, it flashes into steam instantly, expanding explosively. This reaction can fracture the seafloor, launch debris, and displace massive volumes of water, sometimes fast enough to generate tsunamis. One of the most terrifying scenarios is a sudden collapse. If the Axial Seamount's caldera were to cave in, something that has happened in previous eruptions, it could trigger a fast-moving tsunami, with parts of the Oregon coast just 30 minutes away. That leaves almost no time for evacuation. And because these events begin silently deep beneath the sea, traditional warning systems may come too late. Then there's the fury beneath. As lava oozes from fissures, it instantly meets freezing seawater, forming jagged, glassy rock and triggering undersea pyroclastic flows. These underwater surges, scalding hot, gas-charged, and fast, can spread for miles, blanketing the ocean floor and annihilating everything in their path. Entire ecosystems, from coral beds to microbial colonies, can be vaporized in moments. Yet even in this chaos, there's eerie beauty. Black smokers, those towering plumes of boiling, mineral-laden water, erupt like underwater geysers. Sulfur chimneys glow yellow in the darkness, surrounded by bizarre life forms found nowhere else on Earth. Tube worms, ghostly fish, and heat-loving microbes thrive in this hellish realm. A reminder that life finds a way, even where fire and water collide. But every eruption rewrites that world. The seafloor shifts. Entire vent fields vanish or move. Life is erased and reborn in cycles of fire and steam. And with each eruption, the risk grows that these undersea tremors could reach the surface, not just in science journals, but in headlines across the globe. The Pacific Northwest sits on a knife's edge, a region shaped by seismic tension and geological violence. While most eyes focus on the Cascadia subduction zone, the sleeping giant capable of unleashing a catastrophic megathrust earthquake, fewer people realize that just offshore, another threat is quietly shifting: the Axial Seamount. This part of the world is a pressure cooker. The Juan de Fuca Plate, a dense slab of oceanic crust, is slowly but relentlessly being shoved beneath the lighter North American plate. It's a process called subduction, and it's been building strain for centuries. Every inch of movement, every crack, every jolt along this boundary adds pressure to an already fragile system. When the plates finally slip, the result could be devastating. A magnitude 9.0 earthquake and a tsunami that drowns the coastline. Scientists agree, it's not a matter of if, it's a matter of when. And that's where the Axial Seamount comes in. Though it's located hundreds of miles from shore, it's still part of the same tectonic story. It lies directly on the Juan de Fuca Ridge, where new seafloor is born and stress is constantly released through volcanic activity. But that activity doesn't happen in isolation. An eruption at Axial could shift stress along fault lines, triggering seismic movement closer to land. And just as dangerously, a major rupture on the Cascadia subduction zone could destabilize the magma beneath Axial, causing it to erupt prematurely. In essence, Axial is a pressure valve in a much larger machine. And when one part fails, others tend to follow. This is the interconnected nature of geology. Volcanoes and earthquakes aren't isolated events, but pieces of a system that communicates through pressure and release. A shift deep under the ocean could ripple all the way to Portland. A quake on land could stir the sleeping magma offshore. The Pacific Northwest has always been defined by these forces. Mountains were born from their fury. Coastlines were shaped by their violence. And the people who live here? They're unknowingly straddling a fault line that could wake up at any moment. The Axial Seamount isn't just a volcano. It's a fuse, and it's wired into one of the most dangerous tectonic systems on Earth. If the Pacific Northwest is sitting on a geological time bomb, then scientists are the ones listening for the ticking. And right now, that ticking is getting louder. For decades, volcanologists and geophysicists have been quietly tracking the Axial Seamount, aware that its behavior could offer critical clues not just about undersea eruptions, but about the entire Cascadia subduction system. What they've built to monitor it is nothing short of extraordinary. The Ocean Observatory's Initiative, or OOI. Sprawled across the seafloor like a vast digital nervous system, the OOI is a network of deep-sea cables, sensors, pressure gauges, and robotic cameras, all feeding live data back to research labs on land. These instruments measure everything: earthquakes, magma movement, chemical emissions, temperature shifts, and even the tiniest changes in the shape of the ocean floor. For years, the system has quietly watched and waited. But now, that data is telling a different story. In recent months, researchers have recorded a sharp and consistent increase in carbon dioxide and helium-3 gas emissions near the Axial Seamount. These are volcanic gases, molecules that don't just leak from cracks or vents. They rise from magma itself. The more of them you see, the closer that magma is to the surface. It's not just seismic noise anymore, it's chemical proof of a volcano reawakening. At the same time, temperature sensors placed deep within the water column are detecting subtle, unnatural rises in heat. Hydrothermal vents that once released steady plumes are now pulsing irregularly. Pressure readings show micro-changes in the seafloor's elevation, suggesting that the entire volcanic dome is swelling, like a balloon about to burst. These changes are not theoretical. They are measurable, observable, and unprecedented in their scale and speed. And while the public remains unaware, the scientific community is watching with mounting concern. One researcher, reviewing live feed data from the OOI's remote sensors, put it bluntly: "It's whispering louder every day." That invisibility has consequences. Without awareness, there's no pressure on lawmakers. Without urgency, there's no funding for upgraded warning systems, community preparedness, or research. The science exists, the data is clear, but the system is reactive, not proactive. And deep-sea threats don't inspire the same fear or funding as something people can physically see. Talk to residents along the Oregon coast, and you'll find a mix of concern and confusion. Some have heard vague rumors of something out there, while others laugh it off. One man in Newport shrugged and said, "We're used to earthquakes. If the ocean decides to come for us, what can you do?" But others are visibly uneasy. One mother living within a mile of the beach confessed, "We keep hearing about the big one, but no one told us the sea might boil first." Axial is more than a geological threat. It's a social one. The silence surrounding it is a reflection of our tendency to ignore what we can't see. But nature doesn't wait for headlines, and the ocean doesn't care if we're paying attention. By the time people start talking about Axial, it may already be screaming. Long before scientific instruments measured magma or satellites tracked seafloor swelling, the Pacific Northwest had its own warning system: memory. Buried deep beneath the ocean floor and layered in coastal soil are records of past eruptions, some violent enough to reshape the land, stir the sea, and leave scars still visible today. And long before those records were drilled and dated, the people who lived along this coast told stories. Stories of oceans that rose without warning, of waves that swallowed villages, of land that shook and vanished beneath the sea. Recent core samples taken near the Axial Seamount show evidence of massive undersea eruptions dating back thousands of years. Layers of volcanic ash, displaced sediment, and sudden shifts in seafloor topography suggest that these weren't quiet events. In some cases, the geological evidence points to eruptions that may have triggered tsunamis or distant coastal flooding. Some layers contain marine material far inland, debris that shouldn't be there unless the ocean rushed in to claim it. These findings echo the oral histories passed down by local indigenous tribes. Accounts often dismissed by early settlers, but now gaining renewed scientific interest. The Maka, the Yurok, the Quinault, and others speak of times when the sea rose like a mountain or ripped the trees from the ground. One haunting tale describes a day when the water came without wind and swallowed the shore. For generations, these were considered myths. Today, they sound like eyewitness accounts of a tsunami. What if these stories are more than folklore? What if they're historical memories, preserved through oral tradition, of events tied to Axial's ancient eruptions? The timeline matches, the geography fits, and the patterns of destruction described align eerily well with what modern scientists believe could happen again. This convergence of data and tradition paints a sobering picture. The Axial Seamount has erupted before. It has disrupted coastlines, reshaped the seafloor, and possibly sparked events that indigenous people still recount centuries later. The past is not as distant as we like to think. And if it happened once, or many times, it can happen again. The Earth remembers. The sea remembers. The question is, will we? If the Axial Seamount were to erupt tomorrow, there wouldn't be a towering column of smoke or rivers of lava spilling onto the shore. No fiery skies, no cinematic chaos. At least, not at first. The eruption would begin in silence, nearly 2 miles beneath the surface, where the pressure of the deep sea muffles even the most violent forces of nature. But that silence is deceptive. Because the moment magma breaks through, everything changes. A sudden release of pressure could displace massive amounts of water, triggering a localized tsunami with barely 30 minutes of warning for the Oregon coast. Coastal towns could be hit before sirens finish sounding. Roads would flood, emergency responders would scramble, and lives would hang in the balance. The ocean itself would suffer too. Entire ecosystems, hydrothermal vent communities, coral beds, deep-sea species found nowhere else, could be annihilated by undersea pyroclastic flows and suffocating sediment. And then there's the human infrastructure. Axial sits dangerously close to vital undersea internet cables that link the US to Asia and support tech hubs like Seattle. An eruption could sever those lines, crippling communication and commerce in a matter of minutes. In the chaos, ash plumes and volcanic gases could rise into the ocean atmosphere boundary, disrupting air travel and cloud formation patterns. All of it, tsunami, blackout, ecological collapse, could begin with no sound at all. As one researcher warned, it would be silent at first, then it would hit all at once. The scientists watching Axial Seamount aren't alarmists. They're data-driven, methodical, and cautious by nature. But right now, their instruments are sounding the alarm. The GPS monitors are rising. Seismic swarms are increasing. Gas emissions are surging. And the temperature at the seafloor is rising with it. Every sign points in one direction. Axial is recharging. The Pacific Northwest may be one of the most beautiful regions in the world, but beneath its rugged coastline and quiet forests, pressure is building. A deep-sea time bomb is swelling with magma, and with every passing month, the odds of eruption climb. The terrifying part? Most people don't even know it's there. But nature doesn't wait for us to catch up. Like so many natural disasters, Katrina, Fukushima, even the 2004 Indian Ocean tsunami, it's not the eruption itself that causes the most damage. It's our unpreparedness, our disbelief, our delay in taking warnings seriously. So the question isn't just, will it erupt? The question is, will we be ready when it does? Because when the shaking starts, when the sea draws back and the wave rises, it'll be too late to wonder why we didn't act sooner. The Axial Seamount doesn't want attention. It doesn't spit smoke. It doesn't glow red in the sky. It sits in the dark, beneath crushing ocean pressure, whispering through seismic signals and chemical plumes. It is silent, submerged, ignored. But silence is not safety. And if this volcano erupts, it won't just reshape the seafloor. It will test every assumption we've made about readiness, risk, and resilience. It will challenge our emergency systems, our science communication, and our ability to protect the people who live along this beautiful, fragile coast. We can't control the Earth's fury, but we can choose to listen. And right now, the Earth is speaking, quietly, clearly, and urgently. If you found this eye-opening, hit like, subscribe, and tell us in the comments. Are we underestimating the threats beneath our oceans?